Hi, my name is Jeff Dillon. I'm owner of Pure Video TV, and I wanted to talk about a project I'm working on. This is my QuadRocket project, something I'm very excited about. First of all, I think it just really looks cool, so I like that. So I'm going to give you a detailed tour in a little bit, but first of all, I just wanted to give you a high-level background of what I have going here. So I have an Arducopter that I've modified, and I've put 4 solid rocket boosters on it, and then I have a thrust measurement system, a closed feedback loop between the quadcopter and the PC. And so I have an ignition system that ignites all 4 rockets at the same time. It's in a static stand right now, so it's not going anywhere. And ultimately, the way it'll work is once all 4 motors are ignited, the stand will release it. Once the engines are firing nominally, I have about 5 seconds of constant duration thrust. So I'll release the quadcopter. The propellers will provide a small thrust differential to keep it level under full rocket thrust. And I plan to pick up an object, possibly like this. So I have 5 seconds to lift it up and set it back down. Kind of a reverse skies crane maneuver in honor of the Mars Curiosity lander. So this is the quadcopter, and over here is the PC setup. So I have the radio receiver here, an extra data terminal here, laptop here, my TNC packet radio decoder there, and of course the associated data acquisition and ignition electronics. And then over here is the telescope that I use for tracking. So I have a Meade 8-inch LX GPS optical telescope here. I have it connected through serial cable to USB to back to the laptop for control. So the way this works, the quadcopter will broadcast its GPS and altitude information to the laptop. The laptop then controls the telescope, and the telescope will robotically slew and track the quadcopter as it flies. So for short distances between the quadcopter and the laptop, we have the radio, the 3DR radio. Of course, for satellite communications for longer distances, we have a 5-watt Yaesu milliwatt amateur transceiver. I have a Technician's Class FCC license for that. And then mounted on the optical telescope, we have a Yagi antenna for radio reception in the 2-meter bands. And also on the telescope, we have laser modulator, demodulator. So the laser beam will come in optically, will be demodulated through the electronics at the bottom of the scope, and then similarly there's a laser transceiver on the quadcopter too. So once radio reception is, we have full handshaking, then there's also subsequently laser handshaking for high bandwidth communications. So let's go on a little tour of what we got here. I'll show you the setup here. So here's the quadcopter and the custom motors that I have mounted on there. Then below the quadcopter are the thrust sensors, and of course they're connected through their wires back to the sensor unit, and then through USB up to the laptop. Then also from the laptop we have the ignition system, which comes down this way. So we have a digital control unit there, 12 volts at small amperage, triggers a relay at 12 volts at very high amperage. Then that comes up and we do a quad launch of all 4 motors at the same time. Doesn't have to be exact because the stand here has a quadcopter latched down until all engines are firing nominally. So here's the TNC packet radio demodulator, and it's connected through serial connection up to the mounted Yagi antenna that's piggybacked on the back of the scope. Here's the laser system. Here's the optical back end, and then the laser demodulator down at the bottom. And there's my Yaesu 5-watt amateur handheld transceiver. Power for the scope and associated electronics. Scope, antenna, laptop, and quadcopter.